Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Number of Double Heads. It's a probability problem of medium type. You guys can pause and try to solve the problem. So we've been given this coin and we can toss it 10 times. And the output is then going to be basically a string of size 10, right? And what we've been asked is the expected number of double heads that come in that string. So just to take an example, will look something like this. So over here we flip the or toss the coin 10 times, and these are the outcomes that we got. Now first of all, let me give each coin toss an index. So this would be index 1, 2, 3. So by double heads, two consecutive heads like this, what the question means is that they are looking for two consecutive indexes, both having heads. And what we need to calculate then becomes the expected value of the number of such unique index pairs that will be formed. So for this example over here, we could see that index 1, comma 2 is a pair, 5, comma 6 is also a pair, 8, comma 9 is a pair, and 9, comma 10 is a pair. So in total, there are 4 pairs over here. So if we create a random variable, say xn, find as the number of unique such double heads pairs that we get from n coin tosses. And essentially what we have to calculate is e of x of n. Now I'll be noting e of x of n by e of n for the rest of the problem. So a few hints that I give you guys is that first of all, you can see that the question mentions 10 times. Now again, we've used this trick so many times before. Whenever we see a big number, try to think of simpler cases. Well, they've already given us the value, but let's try to still think of them. So the case of 2 tosses or 3 tosses or something like that. And it's always a good bet when a question uses big values that we try to think about the smaller cases and then use recursion. Another hint that the question gives off is since it's talking about consecutive heads everywhere, this hints towards trying to use a recurrence relation between n minus 1 and n. We could try to figure out the value of e of n somehow using e of n minus 1. We've been using this trick in quite a few problems now, and the question, since it's asking about consecutive heads, also hints towards a similar type of solution. Now, coming to the proper solution, imagine that we already have had n minus 1 coin tosses, and now we're having to think about the very last coin toss. Right? While calculating e of n, by thinking about it in this way, we could say that for the n minus 1 coin tosses, we already know that there's gonna be e of n minus 1 pairs that we could have formed, where e of n minus 1 denotes the expected number of unique such pair double heads that we could have formed from n minus 1 coin tosses. So already considering that okay, we're already adding in the expected number of pairs we're going to form from n minus 1 coin tosses, and now we have a potential of adding one more coin toss for the nth flip. So at the ninth and 10th position, well, first of all, this could have been denoted by n minus 1 up until now, and this is, let's say, our nth index, right? Now, the only way that by the nth index we get one more additional value that we can add to e of n is when the 10th flip was a heads and the ninth flip was a heads. And the probability of this happening is 1 by 4. So we could say that, I'm just gonna put these values down below. So there's a 1 by 4 probability of adding one more consecutive pair plus a 3 by 4 probability, since we have to take in all cases. And now these 3 by 4 probability would denote where on the n minus 1th and the nth slots we get a tails and a heads, or we get a heads and a tails, or we get both as tails. Right? So these three cases would lead to 0 additional values. So this now becomes the equation. And this would result in e of n equaling e of n minus 1 plus 1 by 4. And since we know that E of 2 is 0.25 and E of 3, well, this you don't really need E of 3. This, using these two, we could calculate that E of n is equal to n minus 1 whole divided by 4. That's another way of thinking about this problem, and I'll be showing you the website solution since that goes over that kind of thinking. So this is the way that the website does it. So again, up until this point is the exact same. So to explain this problem, first of all, understand that once we have done n minus 2 flips, there's a 1 by 2 probability of getting a tails, and similarly a 1 by 2 probability of getting a heads. And if we get a tails, then the cases ahead of this won't even matter, because if we get a tails, no matter what we get, we can't get another double pair on the last try. So we don't even consider those values. And if we get a heads, then again there's a 1 by 2 probability of getting tails. In this case also we don't get any new values, but in this case where we also get a heads for the nth flip, this would give us an additional double head. So the way this solution looks at the problem is that to calculate E of n, we're saying that there's a 1 by 2 probability that the n minus 1 flips end in a tails. And in that case, E of n is just E of n minus 1, since there can't be any more additional double heads that we can get. So 1 by 2 denoting this probability, the probability of going over this branch, would be E of n minus 1, as the E of n minus 1 are the number of double heads we are going to get in this case, plus the probability of going down the lower branch. Now over here, since we've got two more branches, we have to include those probabilities too. So 1 by 2 for going to along this branch. Now since we got a tails, we didn't add any more new double heads. So basically this was as many as E of n minus 1 double heads only. So this is going to be E of n minus 1 plus the probability of going along this branch, which would be 1 by 2 again, times E of n minus 1 plus 1, because we got a heads on our last turn and on the second last turn. So these two heads are also going to create one additional new double head. So this is the entire equation. Again, solving this, you get to the same situation of E of n minus 1 plus 1 by 4, which boils down to E of n being n minus 1 by 4. And to answer the original question, E of 10 would be equal to 2.25. I hope you guys understood this solution, and thanks for watching.